Good evening, everybody, and welcome to this month's Curiosity Orbit. This is for March 2026, and in the next hour or so, I have a bunch of different articles and news segments I want to go through and talk with you guys about what's been going on in the world of astrophotography in the last month, and also with a brief look at what is to come in the night sky going forward. First of all, of course, before we start, I just want to say a huge thank you to the people that decided to become new members this month, and I have a list. So this month we have Dan Morgan and we have a Michael. So Dan and Michael, thanks a lot to you two for becoming new members on the channel. And in case you guys don't know, members on the channel, of course, gets, depending on the level you choose, you can get stuff like fancy icons when you post comments underneath. You can get discounts, special roles on Discord, those kinds of things. And if you want to support the channel, you can of course go ahead and do that. You can also go and check out the merch store. Where I sell my merchandise. My new favorite mug, the emergency gravity detector. Anyway, let's dive into some news articles. And I want to start out where we seem to be starting out every stream, which is Sky and Telescope. They have an article about a new AI that's being developed. And before you click away, I know we're tired of everything being AI. This does actually seem like it's AI done right. It's called Arteris. Arteris. I'm not sure how that should be pronounced, but it's a new AI that's being developed for. It's just another noise reduction AI, but this one is made for scientific work. So most of the AIs we've seen so far has just been it's been built for astrophotography specifically, which is still very good that people are using models that are designed for astrophotography, but now it's actually not just been built for photographers, but it's being built for scientists, which of course is going to take it to a whole nother level compared to what we've been used to so far. So it is just a noise reduction AI. And we can see a few example images of it here. We can zoom in maybe so we can see it a little bit better. Where they just have the normally stacked images, then they show the images where they use noise reduction, and then they show the same thing, but just with more exposure time, basically. So here they have 8 stacked images. Here they have 168 stacked images, and here they have the 8 stacked, but with noise reduction. We see we get a cleaner signal. Now, it is not quite ready for prime time yet, because one of the things that they noticed when they were doing this galaxy survey, they showed somewhere, I thought there was a better image of it. Maybe not. Maybe I was reading in an article about it somewhere else. But essentially what they're saying is that, yeah, so they took an image, they ran it through it just to see how many galaxies they could detect in the image. And what they found, is that 75% they were able to validate. So the way they've been testing this is they have basically stacked a low number of images, then run it through this AI, and then they try to see how many galaxies they could detect. Then they compared, of course, all the images, and just to see how many galaxies they could then detect where there was no AI, but they just had more integration time. And what they found is that that 75% were actually being validated in the longer exposure image. But that also means that 25% of them were basically made up stuff. And this is why they're saying that it is not quite ready for prime time yet. It's not really there. They say they wanted to have it above 90% in order to be something they would actually use in real world. Usually in science, you would go all the way to 95 before you would begin to use, to say something is scientifically accurate or valid. So I think there's still some work to be done, but it's nice to see that we are getting these things that are not only going to be, of course, making, and hopefully my idea is there's going to be some dribble down later on when these things become fully fleshed out and the scientists begin to use them. They're going to be posting scientific articles about it, and that often means that they're also going to release how they were going to do it as part of the scientific method. When you post an article, you say, we've done this, then other people need to be able to replicate your results to see that they can get the same thing. So they need to basically tell other people how to do it, so they're going to become public knowledge, and then it's a matter of time before someone makes an implementation that can be installed into Cyril or PixInsight, and then hopefully we're going to get scientifically accurate noise reduction in our astro processing tools as well, which I think is really, really cool. So looking forward to that in the hopefully not too distant future. Okay, let's move over. I did briefly talk about this article, not this specific article, but this news in last month's segment. We talked about SpaceX wanting to launch like a million satellites, and we were talking about how that's going to be very, very problematic for people who like to take pictures of the night sky, as if you have a million satellites in orbit. And just for reference, that's going to be approximately, I think right now we have maybe, is it 30 or 40,000 objects? Around at least 20,000. I can't remember how many it is today, but at least 20,000 objects that we are tracking. So going from 20,000 satellites right now up to a million, that's quite a bit of a leap. But anyway, Sky and Telescope also have an article around this, and the overall process, there are two things, right? There is the whole, like, if they begin to collide, you're going to have a problem because then they create a lot of debris, and that debris is going to destroy more satellites, creating more debris, and then essentially you're just going to pollute low Earth orbit, so you can't have any satellites there anymore because they're just going to get destroyed by all the debris floating around there. But there was a very interesting point being made in this article, and I need a tool so I can highlight these for myself so I can find them again when I want to show it to you guys. But one of the points that were being made here is that in order to make this work, they plan to have not just weekly launches, but hourly launches of SpaceX rockets that's going to be launching up, carrying around 200 tons of equipment per launch. So that's quite a bit of stuff that you're going to be putting into space. However, one of the things that they say that yes, it is easier to both power and cool satellites or data centers in space. So what they're going to be using these satellites for is not just Starlink. This is for basically a like massive data center for AI use. They're going to be launching into space. It's a stupid idea. Anyway, what they say is that, hey, basically, yes, it's probably easier to power and cool it out in space, but with those frequent launches, the net gain in terms of pure carbon saving from actually having them in space and having more efficient solar panels because no atmosphere is completely lost due to the massive amount of emissions that all these launches are going to make. So there's pretty much, it's just, you get the same results in terms of, if you look at carbon emission, just with extra steps. You just have a bunch of junk in space now. So I'm not sure there's a whole lot of points to it. I'm not sure if it's cheaper to do it like that than building a data center on the ground. I don't know. Maybe it's because they want to be able to basically have more powerful AI stuff running on people's phone. And if you could just beam that up to a satellite, just because you need it to obviously to be wireless, it would be faster. I don't know if it's that kind of thing they're thinking about. But anyway, those plans seems to still be talked about and still be moving forward. I personally hope that we're not going to see 1 million satellites in orbit, but I'll be keeping an eye on that as well in the future. Great. Next one is a bit more of a scientific one, but I found it interesting anyway, because I think you guys will as well. It has been discovered that the Ring Nebula has a center bar of iron. We are obviously not talking an iron rod going through the center of the of the Ring Nebula. It is just a central bar of gaseous iron, so it's ionized iron gas, if you will, that is sitting there in the middle, which is of course very, very weird. And at the moment, scientists do not have a good explanation as to why that bar would be there. That bar might very well be a disk that we are seeing etch on, and it could maybe be due to some rotation that we're seeing these heavy elements collect into a disk in the middle. I don't know, but it hasn't really been confirmed. Now, the reason why we discovered this now is because up until now, the way that, I should probably say that this was discovered from the, where do they put it? What's the telescope? I'm pretty sure they put the telescope. There. That one. Let me zoom in for you guys so it's easier for you guys to read. There we go. Anyway, the reason why this has been discovered now is because up until what they've done here, what we've usually been doing is either you would take pictures with the more standard filters that we have, right? You know, you would take your oxygen and you would take your hydrogen alpha, and we would look at these different lines that we knew was there. We have, of course, done spectrography on something like the Ring Nebula before, but the problem is when you do spectrography, you take all the light and you just pass it through a prism, split it out into its individual wavelengths, and then you get a spectrum for the entire area. You don't get a picture per se, you just get in your field of view, here is the different wavelengths that you had available. And you can then see, of course, there's iron. So we've known for a long time that it was iron, but we didn't know its physical location, where exactly it was. And what, of course, we can see now on these pictures is that it is located at that center bar there, which is very, very interesting, I think. And I think one of the scientists behind this, he also mentioned that which I think quite interesting. He says that the iron atoms and they emit at 422 and 567 nanometers. So that's well within the range of normal, like the visible spectrum. That's well within the range of our normal cameras. However, as you also say, that you would need a dedicated narrowband filter to isolate it, and these are not commonly used lines. You're not commonly using an ion filter. I don't even think you could buy an ion filter to observe these emission lines. So as he also said, he doubted that such filters exist as any observatory because they're not commonly made. So just very, very interesting. And I think my personal gut feeling is the reason that it's collecting is that some of the heavier elements is going to have a harder time getting pushed out compared to the lighter elements. For kind of the same reason why all the solid planets are at the center of our solar system and all the gaseous planets is at the outer side, because at the beginning, when our star ignited, it began to blow the lighter elements away. They were going to get blown out to the edge of the solar system. The heavier elements, they stayed at the bottom or the inside of the solar system, forming all the terrestrial planets, and all the gas giants were then formed further out. I have a feeling that it is something along those lines, something similar that's happening here, where that iron is just heavy so that it can stay in the middle. There's probably some spin to it, so it forms a disk naturally, and that's why we are seeing this. But all these lighter elements, oxygen, hydrogen, argon, we even see the argon gas here, which is also a heavy element, is having a harder time getting pushed out, but it's not being pulled into a disk for some reason. Maybe a little bit, I don't know. But anyway, apparently the Ring Nebula has an iron bar at the middle that can actually be observed if you can get your hands on a iron emission line filter for these two wavelengths. So good luck finding that. Okay, that was the news, and now we're going to begin talking about the gear launches, because there has been a number of launches of new telescopes and new equipment that I also want to talk about, because there's a lot of fancy stuff. So the first thing I want to talk about was I've translated this site, so if some of the English here is a little broken, it's because the site was originally in in Japanese, so I use Google Translate to get it over to English. So if some of this is a little meh, then it's not because the site necessarily is bad, or it's just because Google Translate. So, Takahashi, Japanese telescope manufacturer, has launched a new telescope. Now, if you don't know Takahashi, these are usually sitting at the premium, borderlining, sometimes also ultra premium range of telescopes. So these guys makes really, really good, high quality telescopes. But they launched a new telescope. It is their FSQ 80FC. So it's an 80 millimeter aperture telescope. And see if we can find some specs here. It looks very nice. This is the that's the wavelength. Yeah, so that's the wavelength, probably the center wavelength. We're going to see here again. Really good transmission across the visible spectrum. Keep in mind that this, what we see here, is of course in microns, so you need to multiply that by 1,000 if you wanted in nanometers. We can also see the specs for it. It's also listed further down. Also, just want to show you here the transmission curve. So here you have, this is transmission at the center, which is called of full transmission, and then it tapers off here out towards the end. We can see here we begin to get a little bit of tapering for crop sensor, and we are still above 95% when we are at full frame length from the center. So overall, really good light transmission there. I'm sure they had some specs for this somewhere. Actually, an actual spec sheet somewhere. No, I was sure I saw that somewhere. Here was a little bit. Yeah, so it's an 80 millimeter lens, 450 millimeter focal length, and f5.6. So yeah, if you are in the market for around an 80 millimeter refractor in the higher end, then you can. And if you're wondering how much you're gonna have to pay for this, it's 500,000 yen, which is, translated that, it's just over 3,000 US dollars, which is, oh, you can't see it because of my camera, hold on. Well, there we go. Around 3,000 US dollars, for those wondering. But that's not the only new refractor that has been announced this month. There's been two new telescopes also that I'm personally very excited about. ASCAR has come out with their SQA lineup, or the SQA 1300. So if you're not familiar with the ASCAR lineup, we can see here that they have their F series, or they have the Apo series, is probably one of the more popular series that I think a lot of guys will have seen. These are their triplets. Very popular. You put a flattener on it, and you have a really, really good telescope. These are very popular, like good quality budget telescopes, but they have a bunch of other lineups. The Apo series sits in the range between being both a visual and also something you can do astrophotography with. You can it's kind of sitting there in between, trying to hit both the visual and the photography market. They also have their PHQ, which is their dedicated astrographs. And they have some really, really cool, really, really good PHQ telescopes as well in this series. You might have encountered some of those as well. But their SQA series is their premium lineup. That's the best of the best that they have to offer. And it's now available in a 130 millimeter variant. So quite a big telescope. And as we can see here, if we jump down to the specifications, 130 millimeter, 624 millimeter focal length. So we are in these relatively fast sub 5 focal ratio. And we can see here there's a quadruplet, so that means no need for flatteners, no need for anything else, and it also means back focus. You don't have to worry about that. You just put it on there, and you're good to go. And one of the cool factors about this is it supports all the way up to medium format sensors. That is bigger than full frame, so you can comfortably fit anything you want on this camera because you don't need to worry about the worry about the backspacing, so you can have all your filter wheels and rotators, and because it has such a large image circle, up to 55 millimeters, that also means that you can comfortably fit a full frame camera and put an off-axis guider in there without any issues, as it's gonna have plenty of room for both of those. So really, really nice, but of course the drawback of this is for 130 millimeter scope, we're looking at a OTA only weight of just over 9 kgs. And if you begin to include tube rings and dovetail plates, we're almost at 12 kilograms. So that's what you get when you begin to move into these quintuplets. That's a lot of glass, lots of glass. Glass is heavy, and that makes them very, very expensive. You can actually see here for the rear end, that actually did list it down here. The rear end connection distances, you need to have a back focus of between or a what they call rear end connection distance. So that's how far your equipment is from the back end of the telescope here. It supports anywhere from between 64 millimeters up to 76 millimeters. So you have quite a bit of space. And as you will probably also see, there are, if I remember correctly, I'm not sure. Yeah, as you can see it here, you can actually see it. You have the focal plane, which is 76 millimeters here behind the M84 adapter. So that means, of course, then the draw tube just moves the telescope or the equipment out until it reaches the focal plane. So you need to be closer than the 76 millimeters. However, if you remove the M48 and you go up to the M76 thread here, you get an additional 7 millimeters, giving you more space if you need those extra 7 millimeters to get in there. But anyway, that's out, and yeah, overall, like a really, really pretty telescope, and I have really high hopes for this. It looks like a really, really solid piece of equipment. And they just posted some sample pictures down here so you can see what it looks like when you take pictures with it. Though I'm a little confused, this picture here cannot have been taken with this telescope. That's a bit sus, because look at those stars. Those diffraction pattern there, that's taken with a nude. Those diffraction spikes, that's not from this telescope. I just noticed that. They claim it is this telescope, though. Guys. Am I the only one that feels like this is a little sus? Unless this is something they're doing on purpose to the stars afterwards, or they used a star field from a Newtonian and the nebulosity from this one. That seems a little sus to me. Yeah, am I the only one? No, I can see Echo here in chat saying that's very sus. I call some things not right here. This looks more like what I would expect from a telescope like this. Hold on. Does this even make sense? I don't know. Anyway, they could use a mask. Yeah, it could be a post-processing things that people actually want the spikes for aesthetic reasons. I don't know, but at least for me, that looks a little sus. But okay. Anyway, if you're in the market for a rather large refractor, there is one here. But as I said, there are another refractor that's also been announced this month. And that's because ASCAR comes out with a 130 millimeter refractor, and then William Optics comes along and they throw down the gauntlet and they say, okay, you want to see what a 130 millimeter refractor can do? Here is the UltraCat 131. Here we go. Okay, so William Optics, of course, for a long time have their CAT series, but their UltraCat is, again, their premium lineup of telescopes. And as the name suggests, this is 131 millimeters. We can see the base layout of it here. 2 elements of super ED glass, a single element of normal ED glass, total 1, 2, 3, 4, 5 elements, as also says here. So it is pretty much a very, very similar design. We're still talking, it's still a 5-element telescope. It's the same, almost within a millimeter, the same aperture. The other one from ASCAR was an f4.8, this is an f4.9, so we're almost at the same focal ratio. However, this one is $600 more expensive. So what do you get for $600? What is that premium price? Well, it has some really nice additions that I kind of like. One thing that maybe that's a little gimmicky, I don't know, but if you notice here, can you see that? There on the focus knob is a thermometer, so you can see the temperature that the telescope is at, which I actually think is kind of cool. I'm not actually sure if this temperature measures the internal temperature, so you can see when this cools down, so you know when the telescope is cooled down, or if it measures the ambient temperature. That I'm not 100% sure of. But there is a temperature. Now, William Optics, of course, they use this very interesting focusing design. It's called the FIFD focuser. And what that means is that as far as I understand, the rear end of the telescope mount here does not move, but the internal glass elements move inside the optical tube. That is the window you can see here. That's also why when you look at it here in profile, look how far forward the focuser sits. Normally, if we just quickly jump back to the ASCAR here, look here. Here you have the focuser sitting where you would expect the focuser to sit, right? Right at the back, because it moves. It's just basically like a sliding draw tube that moves back and forward, moving the camera until it reaches the focal plane. However, what William Optics does is they, instead of moving the rear end of the equipment, they move the glass elements inside the optical tube, which I think is kind of cool. Which is why the focuser is sitting so far forward. And this is also why when you see this window here, this basically shows the focuser position, because usually you would be able to have numbers sitting on the draw tube here, so you could see how many millimeters you've moved it out. So if you know where your focal point is, you could just look at that scale. You can't see that scale when it's all internal, so there's a little window where you can then see it here. That's kind of cool. You gotta give me that. Okay, let's keep exploring this thing. So it has a number of other, if we go over here to the manual actually, it has a number of other very nice features that I haven't really seen in a lot of other telescopes. And this is where you begin to get that premium price. Wow. There's some basic, like, here's this and that, and different screws and stuff like that. So one of the things they have is they have a sensor tilt adjuster. And that means, you can see here on the side, there are Allen keys that basically turns screws inside the mount here. And that allows you to adjust the sensor tilt of the camera without removing the camera. Usually you have to take the camera off, and there's some Allen keys you need to move on the camera body itself. Now you don't. You can keep the camera on the telescope while adjusting your sensor tilt. So you can basically hook this up to Nina or something like that, take a picture with it, make it calculate your sensor tilt, make adjustments by just turning these Allen keys, take another picture, check your sensor tilt, and do that until your sensor is perfectly flat, making sure you have perfect focus across the entire sensor. That is pretty cool, and that's not something that I have seen in a lot of telescopes. Yeah, so basically they show here again how they move the internal thingy bobs, and you can adjust, and you can of course manual how you install what is it called, like autofocuses. Here's another cool thing. You can see here, we can kind of see it on this image here. If we pull this up, you can see there's a knob here, and that is for the built-in field rotator. So the field rotator is of course manual. You loosen this knob here, and then you can rotate the entire back end, and there's a scale so you can see like with degrees on it and stuff like that. However, one of the things that they probably find out is if you want to install a off-axis guider, you can see here that the off-axis guider is gonna interfere with that knob. And you obviously want your off-axis guider to be closest to the telescope, because the usual order going from the telescope is you would have telescope, then you have your off-axis guider, then you have field rotator, then you have filter wheel, and then you have camera. That's the usual order for your optical train if you run everything, right? But if you put the off-axis guider closest in here, you're going to run into an interference here between that knob and that. So what they've done is they've basically just included a grub screw that you can use for the rotator. So instead of you having a knob, you now just have an Allen key you need to turn with an Allen key instead. So you can just remove that, replace that with this, and then you can freely install your off-axis guider without any issues. Okay, that was the UltraCat 131. What was the weight of this? Probably very heavy. Yeah, so the OTA here is again 10 kilograms. I assume that is the OTA weight only, and that is going to be without the tube rings and the plate at the bottom. Anyway, cool. I think these are really cool. I'm a big fan of big refractors. Yes, we have more announcements. More. Oh yeah. Ooh. That UltraCat is amazing. I agree. I mean, honestly, I really like what William Optics is. I mean, can you tell? that's their Zenith Star. Obviously, this is their much cheaper telescopes. But I mean, I really like William Optics. I think they make like great gear. I mean, you're paying for it, for sure. But damn, they make nice equipment. And I mean, between the SQA series from ASCAR and the UltraCat series from William Optics, if I was ever gonna upgrade like that thing there, I would probably be one of those two series where I would go in and look for a new refractor if I decide to upgrade at some point in the future. Because very nice gear. Okay, now let's move over to the next. We have more gear. There's a lot of gear this month. It's just been like flooding with new stuff on the market. We're jumping over to Proxy Sky. If you've been watching and following the channel for a while, you'll be very familiar with this brand. Chinese dude that makes really amazing harmonic strain wave drive mounts. And if you're not familiar with the brand, one of the big selling points of this brand is, here we go, that you can see here that at least the UMI series, they use servo motors instead of stepper motors. I've been talking length about this in my videos, where servo motors, they react faster, and that also means they really like fast guiding pulses. We're talking half a second, really quick. And they use those really fast reaction time of the servo motors and quick guide pulses from the guide camera to give you really good guiding performance. But it also requires quite a bit of your guiding system in terms of cameras and all that. So it's a whole thing. But they have now launched the UMI 17X. You will know, again, if you're following the channel, you will know that I have the UMI 17S. But they now come out with an X variant. So what's new with the X variant? Well, you can see them here side by side. The main difference between the old variant and the newer variant is it's a little bit heavier and it carries slightly less weight. So you can see here you lose, without a counterweight rod on, you lose 2 kilograms of payload capacity and lose 3 kilograms width. So it's slightly less carrying capacity and more weight. So what is the benefits? Well, the benefits is that you now get physical homing sensors on it, and you also get physical limit sensors. So instead of it being electronic, where it basically measures where the motor is and it remembers that electronically, now there is a physical sensor inside it that tells it where to stop and where home is, which is pretty damn cool to see. But the biggest upgrade to this is the fact that as you can see here, it now has USB and power outputs on the saddle itself. But that's not just it. So the power output is of course standard 12 volt power output. It can carry up to 12 volt 10 amps, so plenty to actually power your entire rig through this. And of course you can connect your mount directly on the saddle, which is super, super nice because that means there are no cables that goes across either of your declination or RA axis. And that means cable snag doesn't happen. If you keep those cables short so they don't hang down too loose, they're never going to snag on anything because they're never actually going to move according to the telescope, which is nice. Power button has also been moved up here. They've also upgraded the wedge design. I haven't played around with that, so I don't really know if it's better. I assume it is since they decided to upgrade. But one of the other things that I find really cool with this is if you take a look here on the base of it, it also has, of course, the power input is down here. It also has a mount USB port down here. So that means if you're running something like an ASI Air or a Stellar Vita, you use the mount USB port that sits on the saddle. However, if you want to use this with like your laptop, you don't want the USB port up on the saddle. That's inconvenient because now it's rotating around. In that case, you actually want it down here, close to the base, and then you can use that port instead. So depending on whether you're using with a laptop or whether you're using with an astro computer on the telescope, you can use either of those two ports. Another nice feature is that, look at that. Can we open this picture in a new tab? Can we just zoom in on this? Because, oh, this is just one big picture? Okay, never mind then. Look at that little button there. It says home just above it there. So there is now a button you press, because one of the things I often find is that the ASI or ZW have a tendency to not always talk super nice with the homing system on mounts. At least it seems to be changing from update to update. And I think what Nook, the guy who makes these, he got tired of it, and now he just made a physical button on the thing, so when you're done for the night, you're ready to pack down. What I would usually do is I would then disconnect from my ASI Air. I would then connect over to my mount Wi-Fi to go in and press the home button in the dedicated app for it. Done with that. Now you go over, you press the home button, and because there are physical home sensors, it doesn't need any kind of computer to tell it where home is. It just knows that because of its physical sensors. Press it, it goes to its home position, and then you can power it down and you're ready to go. If you're wondering about this plate here, this plate is for if you want to use a polar finder, so something like a iPolar or Polemaster or something like that, you can basically screw that in here, and then you have that attached to it as well, so it supports that too. I can tell you now, because it has been confirmed, that I will be doing a review of this mount in the future. Exactly when, I don't know, but if you stay tuned to the channel, there will be a dedicated review coming out of this mount. I've been talking to Nook, and he's shipping one over that I'm going to be testing, and I'm going to be doing a side-by-side between these two that I now have, whereas the other one here, the UMI 17S and the UMI 17X, just to take like the older and the newer one, put them side by side, because there is a bit of a price difference. Oh, it doesn't list prices on this sheet here. Okay, fair enough. But the X is more expensive than the S, and you get less carrying capacity. So it's not necessarily like it's an upgrade. It's just a newer version that has some nicer quality of life features, more advanced features with the physical homing sensors. But again, you sacrifice some carrying capacity. So, okay. That was that. I'm going to jump over there. And we're going to jump over to the next. I have one more gear item, and then we're done with gear. Right? Promise. I'm a bit of a gear nerd, if you haven't noticed. So, Olympus has come out with a dedicated Astro DSLR camera. Or is it actually mirrorless? Hold on. Is it mirrorless? Oh my god. I think it's mirrorless. It's likely mirrorless. Okay, my bad. But anyway, they've come out with a Astro version of the OM3. So the OM3 is one of their usual normal camera bodies. They now have the OM3 Astro variant. This is a, as you see, pretty standard camera that comes with some nice Astro features. Of course, most noticeably, where are all the specs, technical specs? All the... What the hell? There was like a gazillion different... like pictures and stuff. Oh, hold on, I probably need to... no, that's the site. Here we go. Here it is. No, what happens? Learn more. Yes, thank you. Okay, that's the site I wanted to be at. Sorry. Okay, so you can see here, of course, that it has its... normally there are filters built into it. So this is essentially just a pre-Astro modded version of the OM3. Normally there are filters, the filter's been removed, so now we just have a factory Astro modded OM3 camera, which is very nice. They specifically improved it down to -10°C, so you can have it out in the cold. Also, USB-C charging, which I think is super nice. So that means usually when you're running DSLRs, you would either have to get these dummy batteries you put in, so you can power it over USB, or you're gonna have to come back and swap batteries during the night. Now you can just plug USB-C into the camera, boom, you have all the power you need all night, which is nice. Also, Starry Sky Astro autofocus, as you guys will know, one of the huge, or maybe you may know, but one of the huge drawbacks when you are running these like mirrorless or DSLR cameras is that they are extremely difficult to focus because they don't have, like, their autofocus and it just does not work. You have to do manual focus because the autofocus is just designed for it. And even I have the Canon RA, so the Canon R Astro modded version of that. And even that, the way Canon solved it was just to give you a 30x zoom on the live view, so you can just live zoom in on a star, and then you have a very close view, and you have to use a bad enough mask, stuff like that. But apparently they now built some software into it, so it can actually do autofocusing on a star field, which is very nice. Yeah, they have some comparison images down here where you can see this is their normal OM3, this is the OM3 Astro. It of course captures a lot more hydrogen alpha, so you can see a lot more in the image. And what we're seeing here is that, what are we looking at here? Can we see this image? Yeah, so this is Orion, right? That blob there must then be the Horsehead and the Flame Nebula. Yeah, so that's the other stars in the Orion's belt, or the sword. But anyway, if you are looking for something that kind of bridges the gap between a normal DSLR, a mirrorless camera, but not really like a dedicated cold Astro camera, you want something that's a little bit in between, the OM3 Astro is now available. Cool. So that was hardware launches this month. Let's go talk software. There's been a few software updates that I want to talk about as well. First of all, from ZWO, we have here 4 days ago, we got the update 2.5.1 update for the ASI Air. There's not a whole lot to it. It's just an update that allows you to now have a custom park position if you are using an ASI mount. So if you're using one of the AM mounts from ZWO and you get this update for your ASI Air, you can now customize a park position. So again, they're beginning to get these more typically observatory kind of kind of features are beginning to show up in the ASI Air now, which I think is interesting in itself, that they're slowly beginning to go in that direction again with custom park positions. We also have in Cyril update, yes, on the 18th of February, we have update 1.4.2. And we were talking about these noise removal scripts. A new one has been added to Cyril. That apparently takes a completely different approach to noise removal than all the other ones. I haven't played around with it myself, but if you have Cyril, then go play around with the new noise reduction over there. They say, again, there's a fundamental different design. Model operate largely on the native image resolution. I think what they're trying to say here is that a lot of the previous noise reduction algorithms would take the image, scale it down, and then work on a scaled down version of it, and then scale up again afterwards, and kind of get rid of noise that way. Whereas this model just works directly in the native resolutions, and it significantly reduces spatial information loss. So you lose less information, retain higher, you get a less blur, because when you do noise reduction, you always get a bit of a fuzzy blur to it, but you're now going to be able to keep more spatial information, so details in the image than you would with the other ones. Again, haven't really played with it, but it would be interesting to try it out. And if you have Cyril, go install the update, give it a go, and see if it actually works. Okay, let me move on and see what else we had. Oh yeah, for all you Mac users out there, there's some good news. Over there. Scope Trader have an article about a software that's just launched into a beta test, so that where they are still testing it's not a full launch yet. It's called Meridian. It's a Mac OS software that works as an astro image that takes FITs or EXIF data, and it basically archives them. It gives you a total, so you can basically search through your archive for different targets, or you can manage your flats and all that. In all that information is basically just stored in an archive where you can begin to search through it and make it easier for you to find your images. I think it's pretty cool. Kind of obviously wish we had something like that maybe we do have something like that on Windows, and if we do, let me know in the chat if you know it right now, or if you're watching this as a VOD later, comment section, because that would actually be pretty cool to have something to organize your images, because right now I just have a bit of a messy folder structure. And that's also what they're saying here, is if you have years and years of astro data, it's gonna begin to be messy and you can't figure out where all the pictures are. And what I usually do is I would actually copy the same calibration files between projects, so I have the same set of calibration files sitting in 10 different folders. It takes up tons of space. You don't need that anymore, as you would be able to basically just take these and look up which ones would fit the different images, and you can search through them, and I think it's pretty cool. Anyway, that's the thing. It's called Meridian. I think it's a paid software. Yeah, so it has a one-time pro upgrade priced at $55. That unlocks an interactive sky map, the wish list, visibility planning, statistical dashboard, equipment management, star extraction, seeing analysis, and plate solving, blah blah blah. It seems there's a free version. If you want the full shebang, it's a one-time payment of $35. So if you're on Mac, then go and play around with it, see if it's cool. Who knows? Yes. I don't think I mentioned this last week. If I did, then sorry for repeating myself. The Stellar Vita got a massive app update. So I think one of the biggest drawbacks of the Stellar Vita in the past has always been that the app was a little clunky to work with. The UI was manageable, but I know from I brought it to a star party and talked with some guys there. A lot of guys were like, yeah, it's okay. They didn't really like the app, yada yada. And I understand. It was a little more clunky to work with and a little bit less reliable, and it just felt less premium than what you get with something like an ASIR. But that is a thing of the past, because now the Stellar Vita app version 2.0 has been released, and what a world of a difference it has made. This has just completely transformed this device into the modern era. It is absolutely amazing. If you have a Stellar Vita, I assume you already played around with the app. If you have not, or if you're just interested in seeing more about the app, I recommend you go and check out my video I made not too long ago, where I go and explore this for the first time. And as you can see, it's a very nice, very modern looking UI. Highly recommend that you go check it out. And again, watch the video. Stellar Vita, huge update out now. If you are interested in seeing what the new app looks like, and if you have a Stellar Vita yourself, and you need to go and get this the new update, because it's very, very good. It just makes this like a real. Now this is actually beginning to not just rub shoulders with the ASIR, but it's actually beginning to, in some cases, overtake it, in my mind. I have a video coming out here that's probably going to be next month. I'm working on it right now, where I was testing specifically all sky polar alignments, and I was comparing how it works in the ASIR and how it works in the Stellar Vita. And honestly, the Stellar Vita is a little bit better, a little bit ahead of what you got with the ASIR. Not by a lot, but still, we're beginning to see areas where the Stellar Vita is actually overtaking the ASIR in terms of features. So anyway, if you want to play around with that, go and get that software update. Nice. Okay, we are getting close to the end for today. I just want to quickly talk about the some of the things that you can see in the night sky in the month to come. Now, there's not a whole lot. It's a bit of a dull month, if you ask me. There's a bunch of like planets and nebulas that's close to each other. But the one thing that I found was a little bit interesting that I should probably have included last month, but I didn't, is Comet C2024E1. It is located right here, close to Alpha Centauri. As you can see, if we scroll down, it had its closest approach here to Earth, right here, which was on February 19th, 17th. Yeah, so on the 17th, it had its closest approach. We are now in March 9th, right? So it's around here right now. Very, very close still to its closest approach. Just zoom in a little bit here. So that. So March 9th is like there. You can see it's very, very close still. It is moving away, but if you are a comet hunter, then C2024E1 is a very, very interesting, very good target this month. So that might be something for you to go out and have a look at. And you can also just go and have a look at it yourself with your visual telescope if you're so inclined. But yeah, go take a look at that if you want to go and look at some comets. Okay, that's all I had for you this time. As always, if you spot interesting news, fun things that you think I should cover in these live streams, then come by the Discord server. Over there's a dedicated channel for the Curiosity Orbit, which is these monthly live streams where I go over all the news. Post the link there, just copy and paste the link in there, and I'll take a look at it, and then maybe I'll include it in the next month segment. So it just makes life easier for me, because I try to keep on top of everything. I can't keep on top of everything. So if you spot something, please go and post over there on the Discord server. There should be a link in the description where you can go and get over to the Discord server. It's also a very nice community. We chit chat over there. People share their pictures. They can give feedback if you're looking for feedback, or if you just want the place to show your pictures to someone and for other people to be inspired or excited about it, then that's a very nice place. Go check that out. Hope I'll see you guys in Discord. And once again, if you want to support the channel, multiple ways you can do it. You can just drop a like on this live stream. You can also subscribe to the channel. There will be loads and loads of new videos coming out later this month, of course. And also, you can support it with buying some merchandise. I showed at the beginning the emergency gravity detector mock, where you, if you're ever in need of making sure gravity still works, you can always just yeet the mock and see if it breaks, and if it does, then gravity probably still works. Also, I have my caution may randomly start talking about telescopes. You can both get this as a water bottle, as a t-shirt, a bunch of other things. Check it out, and of course also you can get my book, which has been buried underneath all my camera stuff. Here we go. The Cosmic Field Guide, a very nice handbook for astrophotographers with loads of various challenges you can try. There are like darkness plots. Well, there's the camera there, so you can see when sunset happens different places in the world, and when you go into astrodark and nautical darkness and all that kind of stuff. If you want to know when the different meteor showers are happening, there's a handy table. The whole thing, of course, made with a spiral back, so it's designed for you to take with you out in the dark when you're out there. This is also why you will feel the paper it's printed on is extra thick, extra heavy, so that it doesn't get destroyed completely if it gets a little bit of moisture. Wrapped in a plastic outer layer to protect the book when you have it out with you. And of course, with a spiral back, so if you want to see a specific page, you can put it down. It doesn't close on you. You can actually put it away and have it as a reference. Really, really fun. Go check it out, deepspacebook.com. Also, for all you guys in the US, it is as a ebook that you can buy, because shipping to the US has gotten outrageously expensive, to the point where it is more than the price of the book just in shipping, and I don't feel like that's fair until I find a cheaper way to get this thing over the Atlantic. Unfortunately, you guys in the US, you're gonna have to keep it on your tablet as a ebook. Oh my god, cameras everywhere. There we go. But that's it for this month. Hope I'll see you guys in Discord. Have fun, clear skies, and I'll see you guys next month.